So this is the arithmetic part of the GMAT sum of the problems, right? Basic operations. So in this problem here, what we see is it says what is the sum of the integers in a table above. What we usually want to do in this case is want to match numbers that could cancel out. This is an addition, because the word sum itself means, adding numbers, right? So see here I have the 2 and a negative 2 right here, 2 and a negative 2, and I know that 2 plus negative 2 equals 0, so these two cancel out, right? And then I have, let's say, and I'm going to go, this will take a bit, but the first time, but the only purpose of this problem is to figure out the numbers, to kind of practice on addition and subtraction of numbers. So we have a positive 6 here and a negative 6 here, so those go away, and I'm gonna like fill them up like this, so just get rid of them. And then we have a positive 4 and a negative 4 here, and we'll continue in this manner over here. So let's say we have a negative 18, positive 18 going away, negative 12, positive 12 going away. Let's continue here. So we have 21, negative 14, 7. So, just mix and match pretty much. So 5 and 5 is 10, and 10 is 20, and the negative 20. So these all go away. Now combining many of them is better because you can see you can get rid of more of them at the same time. And then you have negative 12, and negative 8 is negative 20. So and positive 20, they will all cancel out, as we can see. Negative 16 and 15 will give you negative 1, which will go out with this 1 over here as we go, and then we continue. So we have negative 6, negative 12 is negative 18, and negative 18, negative 22, and negative 8. So see, negative 8, negative 14, negative 12, negative 24, negative 30. This all go away with a positive 30. See, we're actually kind of getting rid of a lot of stuff. So if we see here, we have negative 10 and 7, which if you add them up will be negative 3, and they will cancel out these 3 over here. And then we have negative 24, and negative 24 is negative 48, negative 48, and we don't have any negative 48. Oh, negative 42 and positive 42 go away. 35, no, nothing good. Negative 30, and that, no. 21 and 14 would be 25. 35. So we have these numbers left over here. So oh, and then we have negative 14 and 14 just go away. So these are the numbers that are left: 3, 6, 9, 21, negative 24, negative 28, negative 36, negative 30, and again negative 24 here, 25, 35, 49, 35, 28, 21, 15, and 7. So you can make a list of them. You can say 3 plus 6 plus 9 plus 15, and then you can do all the positive numbers together, plus 21 plus 21 plus 7 plus 28 plus 35, and then plus 35, and then you can do all the addition here, and then you can do all the negative numbers. So these are the positive numbers. You can do all the negative numbers here, all of them, and then you can find out that the answer would be negative. It would be positive 112. So the whole purpose of this is to make sure that you know how to do the additions. So again, if you look at the ones that I canceled out, follow the last few steps, you can actually figure out how to do the problem. On this second problem over here, This is a simple addition table. So what you have to figure out is the unknown parts, right? So for example, you have 4 plus x. 4 plus x equals 1. So if you minus 4 on both sides, you find that x equals negative 3. And then you have 4 plus y equals negative 5. So if you minus 4 on both sides, y equals negative 9. And then you can find out what the rest of these guys are. So for example, you know that now x is 3, so e plus negative 3 will equal 7. I'm talking about e being this one over here, and x now being negative 3, and y being negative 9. So adding this, and e will be equal to 10, so this will be equal to 10. So as you can see, continuing in this manner will reveal all the remaining letters which you are looking for, n and m, and your answer should be 5. So I encourage you to continue the problem on your own. It's not a very difficult problem. It is just a matter of understanding that this is an addition table. In this problem here, well, actually we went over this, Kelly, so I'm not going to do that. I'm going to go over the ones that we have not done. We went over this. We did this. So this is a exponent problem here. The exponent problem, 5 to the 21st times 4 to the 11 equals 2 times 10 to the n. The whole goal here is to figure out how to put this side of the problem to look like this side of the problem. Okay, so we want to have something that says 2 times 10 to the n. Right, that's our ultimate goal, right? So we have here 5 to the 21, and then we're going to write 4 as 2 to the second. So 4 itself is 2 to the second, and then to the 11th power. Okay, so the next thing we do, we have 5 to the 21st times 2, and then now using that exponent rule, we have 2 to the 22nd. So we have 5 to the 21st, or actually I'm gonna rewrite it with a 2 up front. 2 to the 22nd times 5 to the 21st. Here we can write 2 to the 22nd as 2 to the 1st times 2 to the 21st. But how did I do that? Well, we know that a to the x plus y equals a to the x times a to the y. So if you have, for example, 2 to the 5th, you can write it as 5. You can write it as 2 plus 3. So you can write it as 2 to the 2nd times 2 to the 3rd. This is an exponential law. We have seen this one plenty of times. Times 5 to the 21st here. Okay, so now going back here, we're gonna gather this part here. We're gonna look at this part over here. We know by a to the x, b to the x is equal to ab to the x. This is a property. So our a in our case would be 2, our b would be 5, and our x would be the 21. So you have 2 to the 21 times 5 to the 21, which will go to 2 times 5 to the 21, which is 10 to the 21. So here we have 2 times, and then this part here, as we observe from here, would be equal to 10 to the 21. So we achieved our goal. Our goal was to write this left part of this equation the same as the right part. So on the left part we have 2, we have 2 times 10 to the 21, and on the right side we have 2 times 10 to the n. Okay, so the question is, what is the value of n? Well, n, for these two to be equal, n has to be equal to 21. So n equals 21, and then you can uncover the answer, and that would be it. This is a more difficult. Oh, this is an interesting problem. This is one that touches upon the rules of exponents, right? So you have 2 to the 5th plus 2 to the 5th plus 3 to the 5th plus 3 to the 5th to the 5th. Okay? So you can see that the problem, but the answers here are, 5 to the 6, let's say, right? Because you see, or 13 to the 5. Be careful of this answer. Lots of people would do 2 plus 2 is 4 plus 9 is 13 and then put the power. But no, we're going to combine like terms. So if we have 2 to the 5th plus 2 to the 5th, would be, you can hear the ambulances outside here. Funny. Okay, 2 to the 5th plus 2 to the 5th would be 2 times 2 to the 5th plus 3 to the 5th plus 3, there's 3 of them, so 3 times 3 to the 5th. But what do we have in here? We have 2 to the 1st and 2 to the 5th. By using the exponent addition rule, we have 2 to the 6th. And here we have 3 to the 6th. So this would be our actual answer, would be this one right here. So this is the okay answer. And again, we use the idea of, a to the x times a to the y equals a to the x plus y. Again, 2 to the 1st times 2 to the 5th equals 2 to the 1 plus 5 equals 2 to the 6th. So this is the idea that we use to do this problem, combining these like terms. And as I said before, addition is a faster a multiplication is a faster version of addition. So instead of writing something 3 times, we say 3 times that. Instead of writing something 2 times, we say 2 times that thing. Okay? So that's what this problem is all about. Again, in this problem here, it says if k is a positive integer, which of the following is equivalent to 3k plus 3k, right? So you have how many 3k's you have here? That's the question. Again, gotta be careful because 6 to the 2k is one of the answers here, which is wrong. 6 to the k, we don't add those things, we don't multiply, we don't do this thing either here, because 3k plus 3k is 2 times 3k, and the bases are not equal, right? So not equal bases. Okay, exponents are not equal. So we can't use ax times ay equals ax plus y. We can't use this, right? And that we can't use the fact ax bx equals ab to the x. We cannot use either this one here because both 2 and 3 are different, and this is 2 to the 1st, this is 3 to the k. But yes, all you have to do is to say 3k plus 3k is 2 times 3k, because that's what you're doing. You're adding that 2 times, and the multiplication version is the fastest way to express addition. In this problem here, what you need to do is you need to multiply these numbers here, the 4, 5, and the 6, the 10, and the 10, and the 10 here. So 4, 5, and 6 would be 120 times 10 to the 2nd times 10 to the 1st times 10 to the 4th. 2 plus 3 is 5 plus 4 is 9. 10 to the 9. Okay? Now, equals 1.2 times 10 to the n. So what you're going to do now is you're going to write 120 as a 1.2. So you have to move the decimal 1, 2 over here. Okay? So when you move the decimal to the left, right, you move it 2 times to the left. This is a rule. You're going to add those 2's to the 9 here. So it's going to be 1.2 times 10 to the 9 plus 2. 1.2 times 10 to the n. So this would be what? This is 9 plus 2 is equal to 11, right? So then n is equal to 11. So you moved it 2 times to the left. Those times that you move the decimal point to the left side are added to the power of the 10. If you were to move it to the right, you will subtract those times, the times of the movements that you did, you will subtract them from the power of 10. Okay, so if in case it was 0.012 times 10 to the 9, and then you had to move this 1, 2 to the right, this would be 1.2 times 10 to the 7th. You would subtract those from that, you know. So you would take those out from the 9. So that's pretty much it about this problem. N is equal to 11. The answer is this. 11. In this problem here, we have another 1/4 times 20 to the 8, right? You see that there is no fraction. So you're going to say, how to get rid of the fraction? Well, again, we're going to work with basic, very basic exponential rules, right? So if you have 20 to the 8, right, I'm going to split this as 20 to the 1st times 20 to the 7th. 7 plus 1 equals 8. Then I have 1/4 times 20 times 20 to the 7th. So 20 divided by 4 is 5. So this is 5 times 20 to the 7th. So if you look at it, the answer would be right here. So all you're doing is you're taking that only a 20 to the 1st power, because only things to the 1st power can divide with things to the 1st power. So there you go. You can do that, and be the end of the problem. This problem here is a bit fun because you're working with powers, etc. So, you know, what I suggest in this case is you have 2 to the 0, 2 to the 1, plus 2 to the negative 3 over 2 to the negative 3 plus 2 to the negative 1. So in this case, 2 to the 0 is a 1, plus 2 plus 1 over 8, which is 2 to the negative 3. And then you have 1 over 8 plus 1 over 2. So I would do the top part first, you know, add those guys up, and I'll do the bottom part second, and then I would divide. So 1 plus 2 plus 1/8, and then 1/8 plus 1 over 2. So, you know, this would be equal to 8 plus 16 plus 1 over 8, which would be 24, 25 over 8. So you can tell now which one it is. And then you have 10 over 16, right? 10 over 10 over 16. So then you have then you divide this 25 over 8 divided by 10 over 16, and you have 25 over 8 times 16 over 10. So this cancels out, becomes 2, and the 5 becomes 2, and the 5 here. So 2 divided by 2 will be equal to 5. This is just fraction division. You can do this just to practice. This problem here, you have 5 to the 5th, 25 to the 25th power. So 5 to the 5th, I'll write it like this, times 25 is 5 to the 2nd, all to the 25th power, using the multiplication rule here, 5 to the 50, and then here you use the addition because they're same base, so it's 5 to the 5 plus 50, 5 to the 55. So what did we use in here? We used the idea of a to the x is equal to a to the x, and then we use the a to the x to the y is equal to the a to the xy. We use a to the x times a to the y times equals a to the x plus y. So these are the all the rules that we use. That's why I emphasize to say learning the rules. It's a very important thing to do. So I'm going to leave it to here for now, and then we'll send you more slides later on. So thank you, Callie, and hope everything goes well today. Thank you.